Hello everyone, this is DSA Zindabad. Today we are going to solve the 21st question of actual DSA sheet, and the question is majority element. Now let's look at the question. Given an array nums of size n, return the majority element. The majority element is the element that appears more than n by 2 times. You may assume that the majority element always exists in the array. So now what does the question says? Question says you will be given an array. From the array you just need to find the majority element. And what's the definition of majority element? Whose frequency is greater than n by 2, right? Now let's look at the example 3, 2, 3. From this given array, like we can directly see 3 is our majority element because it occurs more than n by 2, right? Greater than equal to n by 2, right? And here n is equal to 3. So 3 by 2 will be equal to 1.5. So 2 is greater than equal to 1.5, right? This is the condition. That's why 3 is a majority element. And it is also mentioned over there, like you may assume that the majority element always exists in the array, right? We need to consider this case also, right? Now consider this example, which is 2 2 1 1 1 2 2, right? This is an example. From there we can directly see like 2 appears, the frequency of 2 over there is 4 and the frequency of 1 over there is 2. So since this array is of size 7 and 7 by 2, right? This will be our n by 2, right? So in this case, like 2 is our majority element because 2 occurs more than n by 2, right? So we just need to return the majority element from the given array, right? So now let's jump into the approach and try to figure out how we can proceed with this question, like how we can solve this question. So initially, let's talk about the brute force approach. Brute force approach, let's say this is our example: 2 2 1 1 3, and we'll have 2 2, right? Let's say this is a example, right? First thought which comes in our mind, we just need to count the frequency of each element, right? And after like calculating the frequency, what we need to do, we'll just take the maximum frequency from the given array, and we'll check whether its frequency is greater than that of the n by 2. If this is the case, then we just need to return this as our majority, right? This is the brute force approach. Like let's say first of all, we'll calculate the 2's frequency, which will be 1 2 3 4, right? And for 1 we'll have 1 2, and for 3 we'll have 1. So from this we can directly see like 4 is the highest number of frequency over there, and the size of the array is 7. So 7 by 2, right? This will be 3.5, and 4 is greater than that of the 3.5. So ultimately 2 will be our majority element, right? This will be our answer. So we just need to iterate over the array like one by one for each and every element to count the frequency, right? So this will require big of n square because like let's say we are at this element, so we'll try to calculate the frequency of 2, like we'll increment the count of 2 and again 2, again 2. Now after this, we'll came to this element 1, and we'll again try to calculate the frequency, right? So we'll have two loops with the help of which will be calculating the frequency of each and every element, right? And when you talk about the space complexity, it will require big of one space because we are not using any other space for like storing all of this. We are just using variable to store the frequency of each and every element, right? So now let's try to reduce the time complexity of this approach, right? So now let's talk about the better approach. Better approach, right? So let's take the same example: 2 2 1 1 3 2 2, right? This is our example. Like when it comes about storing the frequency, like what sort of data structure we can use? We can use hash map for the same, right? For storing the frequency of each and every element. So what we'll be doing, we'll directly store each and every element in the form of key and value pair in hash map. Key value pair. Here our key will be element and the value will be frequency. So this will require big of 1 for storing like frequency of each and every element, and we just need to traverse over the complete array. So the time complexity would be big of n, and the space complexity will also be big of n for the storing each and every element, right? So this will ultimately be 2, and the frequency of 2 will be 4, and from there like the frequency will go for one element and its frequency will be 2, and for 3 its frequency will be 1. So our hash map will look something like this, and from this we can directly see like whose frequency will be maximum. This will be our majority element, because it is mentioned in the question like there always exists a majority element in a given array, right? That's why like whose frequency will be maximum, this will be our answer, right? And it is also mentioned like there exists only one majority element in the given array, so the majority element will be one whose frequency will be like highest, right? I hope this makes sense to all of you guys, right? So now let's talk about the optimized approach, like which will require big of one space, like, right? So now let's talk about the optimized approach. Optimized approach, right? So now when you talk about the optimized approach, like there is one algorithm, Moore's voting algorithm, Moore's voting algorithm, right? So now we'll be using Moore's voting algorithm for this question to solve this problem in big of one space complexity. And the one main condition for Boyer-Morris voting algorithm is like there should be a majority element, right? There should be majority element in the given array. If there is no majority element, then this algorithm will not work, right? There should be majority element and it should occur n by 2 times in the array, more than equal to n by 2, right? More than equal to n by 2. So now let's talk about what exactly Moore's voting algorithm is like. So Moore's voting algorithm is something like this. How this algorithm is like, initially, start we need to start with first element as majority element, right? First element as our majority element with votes equal to 1, right? This is the first condition, and the second, if a particular element is equal to majority, then what we need to do, then we need to increment count. Count over there is votes, right? That's why it is called like Moore's voting algorithm. If element is not equal to majority element, then what we need to do, we just need to decrease the votes or the count, right? And there are two more conditions in this condition when element is not equal to majority. Like if votes become 0, then we need to update majority element, right? Then we need to update majority element. And one more thing, like we need to set votes equal to 1 for newer element, for new element. With these three conditions, Moore's voting algorithm will work, right? These are the conditions like which we need to keep in our mind while performing, while making use of like Moore's voting algorithm, right? Now let's do a drag on a particular example so that this algorithm is clear to all of you guys, and I'll also attach the GFG link for this algorithm so that you guys have a better understanding like what's the intuition behind this algorithm and how this algorithm actually works and how this algorithm came up, right? So now let's do a dragon for the same. Let's take this as a our array 2, 2, 1, 3, 1, 2, 2. Right? This is our array. This is our majority, right? And this will be our votes for storing all the votes. Initially, what does the algorithm says? Like to start with, let the first element to be majority. So we'll start with this element. So this will be our majority element, and its frequency of votes will be initially 1, right? So we'll increment to this, and if our element equals majority, what we need to do, we need to increment the value of the count. Count over there is votes, right? This second condition, right? If element equal to majority, then we need to increase the votes for this majority element, right? So since we came across again 2, so its frequency now become 2, right? So we'll again increment the pointer over there. So this time, like as you can see, like if element is not equal to majority, then we need to decrement the value of the votes, right? This will become 1, right? Again, we'll be pointing to 3. So now 3 is not equal to the majority element, so we'll again decrement the value to be like by minus, right? Because element is not equal to majority element. So there is one more condition, like we need to check if element is not equal to majority, then we need to decrease the vote, right? This is what we already did for the case of third element. If votes equal to 0, then we need to update majority element, right? As you can see, like when we came across this 3, votes become equal to 0. So we need to update our majority element to 3, right? And we also need to set the votes to 1 for the newer element, right? So we need to set the votes to 1 for the newer element because 3 is the newer element over there, right? We'll again try to like increment our pointer. Now it is pointing to 1 over there, right? 1 over there. Since 1 is not equal to the majority element, so we'll decrease our votes. Now again our votes become 0. So again we need to update our majority element. So our majority element will be 1 this time, and we need to update our votes to 1, right? This is the condition. So we'll again increment our pointer. Now we'll came across 2. So since 2 is not equal to the majority element, so what we need to do, we need to decrement the count of the votes. Now after this, since votes again become 0, so we need to update our majority element. Again, we need to set the value of the votes to be 1. Again, we'll increment our pointer. Now, since this is equal to the value of the majority element, so there is no need to change the majority element, and we'll directly increment our votes. So in this way, we can directly see like 2 is our majority element. 2 is our majority element. I hope this approach is clear to all of you guys. Like how we are using Moore's voting algorithm there, like, and what's the like algorithm says. Like these are, we just need to follow these 3 conditions in order to apply Moore's voting algorithm in the given problem, right? So now let's try to code this thing up so that you guys have a better understanding, right? So here we are. Initially, we'll be having int majority equals nums of 0, right? And the votes will be equal to 1, right? So we need to iterate over the array I less than nums dot size, right? I plus plus. In this, we need to check if votes equal 0, then what we need to do, we need to increment the votes and also the majority element to be nums of I, right? Now, else if majority equal nums of I, then what we need to do, we just need to increase the votes for this. Otherwise, we need to decrease the votes. Votes minus minus. And at the end of this, what we need to return, we just need to return the majority element. Majority element. Now let's run this. Yeah, this ran perfectly fine. Now let's try to submit this thing. Yeah, this is submitted. Now let's discuss the time and space complexity for the same. So here we are. Like since we are just iterating over the array, so it will require big of n time complexity, and the space complexity would be big of 1, since we are not using any extra space, right? I hope this approach is clear to all of you guys, like how we are applying Moore's voting algorithm in our problem, right? Thank you so much for viewing the video till the end. Please like, share, subscribe, and comment if you have any doubt. Thank you so much.